Discuss about the merge sort. We have the merge sort. In case of merge sort, initially we are going to discuss about the merging algorithm, or we can say merging procedure, and with the help of this merging procedure we are going to do the merge sort. Okay, now let us see what is this merging procedure. Assume we are having an array like this, which is containing the data 0, 1 or 0, 3, 5, 7 and 8, and then we have the data which is 1, 2, 3, 4, 6. Now you can see in this array, from this part, that is from P to Q, the data is already sorted, and from Q plus 1 to R, the data is already sorted. Now this merging procedure is, we are going to use this merging procedure in such a way that this merging procedure will make this complete array as sorted array. So what we are going to do here is, initially we are going to copy all this data into a new array, and we are going to copy all this data into a new array. So let us suppose for this purpose we are going to use these two arrays. The number one is the left array and the second one will be our right array. Okay. Now in the left array we are going to copy all this data. So we'll be having 0, 3, 5, 7, 8, and here we'll be having 1, 2, 3, 4 and 6. Now in this array we are going to use one extra space. Here we are going to use one extra space, and here also we are going to use one extra space. Now in this extra space we are going to store some very big number. Assume that number is tending to infinity. Here also we are going to store a very big number. Okay. Then what we are going to do is, we are going to use two pointers. So one pointer will be I, and here we are going to use a pointer J, and then here we are going to use a pointer which is K. So this pointer is basically just keeping track of the index locations. So what our aim is, we are going to compare the values which is pointed by I and J, and if this value, or if the value which is pointed by I, if this value is less than equal to this value, then we are going to copy this value into this array. Otherwise we are going to copy this value into this array. Okay. So initially let us see, we have 0 and 1. So in the first case, the case pointing to the index location P. Now compare 0 and 1. You can see 0 is less than equal to 1. Therefore what we are going to do is, we are going to copy 0 here, and because we copied from this array, we are going to increment the value of I. So I will be pointing here, and here K will be pointing here. Okay. Now compare these two values. You can see 1 is less than 3. So because 1 is less than 3, therefore we are going to copy this value into this array, into this location, and then we are going to increment the value of J. So we are going to copy 1 here. So 1 will come here, and then J will come here. Okay. And then now compare these two values. If you compare these two values, you can find out that 2 is less than 3. Therefore we are going to copy 2 here, and then we are going to increment the value of J. Now compare these two values. Now if you see these two values, now 3 is less than equal to 3. Therefore we are going to copy the value from the left array. So this 3 will be copied here. So this 3 will be copied here, and then we are going to increment the value of I. Now see, this 3 is smaller than this 5. Therefore we are going to copy 3 here, and then we are going to increment the value of J. Every time we have to increment the value of K whenever we are going to copy some value here. Now compare these two values. 4 is less than 5. Therefore we are going to copy 4 here, and then we are going to increment K and J. So this 4 will be copied here. So J will come here and K will come here. Now compare these two values. We have 6 and 5. If you compare 6 and 5, this 5 is smaller than 6. Therefore 5 will come here, increment the value of I, and K will come here. Now compare the values 6 and 7. You can see 6 is smaller than 7. Therefore copy 6 here, and then increment the value of J, increment the value of K. Now as you can see, the last location we have stored infinity or a very big number. This means whenever I'm going to have, whenever I've copied all this data into this array and we have some data which is left into one array, the data will always be less than infinity, so we are going to copy all this data into these locations. Okay, now what I'm saying is, now compare 7 infinity. You can see 7 is always less than infinity, therefore we are going to copy 7 here, and again we are going to increment the value of I, so k will be here, right? And then you can see 8 is less than infinity, therefore we are going to copy 8 here, and then increment the value of I and increment the value of k, or you don't have to increment the value of k. Now after this complete case, you can see this, all this data, which is this complete array, is all in sorted position. We have the data array is 0, 1, 2, 3, 3, 4, 5, 6, 7, 8. Now you can see this complete data is already sorted. So this was the merging procedure. Now let us see how we can write a program to perform this merging procedure. So initially we are going to write an algorithm here. So here we are going to assume that we have a point P, we have a point Q, we have a point Q plus 1, and then we have a point R. So from P to Q data is already sorted, and from Q plus 1 to R the data is already sorted. We just have to merge all these data items. Okay. So we are going to write this procedure, which is the merging procedure, or you can say the merge procedure, which is going to take a reference to this array A. So we have a reference to this array A here, and then we should have the point P, the point Q, and the point R, or you can say index location P, Q, and R. So we have P, Q, and R. Okay. Now we want to get what is the number of data elements between P to Q. Now if you see this P to Q and we want to find what is the number of data elements, and we do Q minus P, then we are not exactly going to get what is the number of data elements here. The reason is, let us suppose we are having this array which is having the following index locations 4, 5, 6, 7, and it is having some data items, assume A, B, C, D something. Okay. Now assume this is P and this is Q. If you do Q minus P, then you are going to get 7 minus 4, which is equal to 3. And the number of data elements here are 4, right? In the same way, whenever in this case you are going to make Q minus P, then you are going to get the data items which is 1 less than the original number. Okay. So to get this size, we have to make Q minus P plus 1. So we are going to take two variables, which is the variable n1, which is going to store Q minus P plus 1, and this Q minus P plus 1 is just going to tell what is the size of this array. Now we want to find the size of this array. So in this case you have Q plus 1 to R, right? So this Q plus 1 to R, if you do R minus Q plus 1, then this is going to give you one data item which is less. That means if the number of data items is 4, then you are going to get 3 here, right? So to get the original number of data items, you have to add plus 1 here. Okay, sorry, you have to add plus 1 here, then this will become R minus Q minus 1 plus 1, and 1 to 1 cancel, so therefore this will be R minus Q. That means if you want to get the number of data items in this case, then it will be R minus Q. So we have a number which is N2, which is going to store, which is R minus Q. Okay. Now we have to declare two arrays, which is the left array and the right array. The size of left array will be 1 greater than this size. The size of right array will be 1 greater than this size. Okay. So we have the two arrays. We have two arrays. Number one is the left array, which will be of size n1 plus 1, and we have the right array, which will be of size n2 plus 1. That means this size will be 1 greater than the original size. Okay. And then what we want to do is, we want to copy all this data into the original array, or before that we have to copy this data into this array. That means we want to copy this data here, you want to copy this data here, you want to copy this data here, and so on. Okay. Now for this case, we have to map these index locations, and we have to make this data to be copied here. So how can we map this index location? Just see, we have to make for, let us suppose we have two variables I and j. So for I, is equal to P to Q. That means there will be a variable I which you run from this to this, and every time from, if we have the index location P, then we have to copy this index location P into this array, which will be having index location 1, 2, 3, 4, 5, 6. Here we have 1, 2, 3, 4, 5, 6. We want to copy the data which is stored in the index location P to the index location 1. We want to copy the data which is stored at the index location P plus 1 to the index location 2. We want to copy the data which is stored at the index location P plus 2 to the index location 3. Therefore, we have to map all these index locations, right? So, what for that we have to do? We have to do left of I minus P plus 1 is equal to A of I. Okay. Now, what this do? Now, let us see here. We have left of I minus P plus 1. So, initially the value of I is P. So, this equation will become P minus P plus 1 is equal to A of P, which will be left of 1 is equal to A of P. That means, in the index location 1, we are going to store what is the value stored in the index location P. Now, the next time the value will be P plus 1. So, it will be left of P plus 1 minus P plus 1, which is going to store the data which is stored in the index location A of P plus 1. So, here P to P cancel. So, we have left of index location 2, that in the index location 2, we are going to copy the data which is stored at the index location P plus 1 in the original array. Okay. So, after this, we have to make, obviously we have copied this data, now we have to copy this data items into this array. So, we have to make for J is equal to Q plus 1 to R. We have to make this loop which is from J is equal to Q plus 1 to R. That means, whatever the data which is stored at the index location Q plus 1, we want to copy this data to the index location 1. So, what are the data which is stored at the index location Q plus 2, we want to copy this data to the index location 2. Whatever the data which is stored at the index location Q plus 3, we want to copy this data to the index location number 3. Okay. So, for this, what we have to do? Write of J minus Q is going to store the data which is stored at the index location A of J. Okay. So, write of J minus Q. Initially, what is the value of J? It is Q plus 1. So, Q plus 1 minus Q will be 1. Next time it will be Q plus 2. So, Q plus 2 minus Q will be 2. That means, in the index location 1, we are going to store Q plus 1, this data. In the index location 2, we are going to store this data. In the index location 3, we are going to store this data, and so on. Okay. So, these two for loops are just going to copy all this data from this array to this array. Okay. Now, what we want to do is, we want to perform this merging procedure where we have to copy all this data back here, all this data back here in a sorted manner. But before that, you should know we have used some location which is storing infinity, that is a very big number. So, assume we have in the index location left of n1 plus 1, we are going to store a value which is very big, infinity. In the right of n2 plus 1, we are going to store a very big number which is infinity. Okay. Now, let us copy this data back to the original array. So, before this, let me just clear this up. Now, what you want to do is, we want to copy this data into the original array. So, for that, for this purpose, we are going to use the pointer k. So, we have a pointer k, which is storing the index location p, right? And then we have to, again we have to make I to point to the index location 1 and j to point to the index location 1. Therefore, we have to make I is equal to 1 and j is equal to 1. So, I and j both are started pointing to the index location 1. Now, we have to make in the original array for k is equal to p to r, if a of k, or here you can do a very simple modification. So, let me just write it here. What you can do here is, if left of I is less than equal to the right of j, that means whatever the location pointed by I, if this data is less than equal to this data, then you want to copy this data into this array and then you want to increment the value of I. So what you want to do is, you want to make A of k store the value of left of I, that means you have copied this data into this location and then you want to increment the value of I. Okay, so after this, and if this data is not less than equal to this data, then you have to copy this data into this location. So else what you have to do, A of k is going to store the value pointed by right of j, and then you have to make j plus plus. Okay, this is your complete merging procedure. So let me just summarize everything again. In the merging procedure, we have used an array A which is sorted from the location P to Q and from Q plus 1 to R. So we have the point which is Q. That means from P to Q the data is already sorted. From Q plus 1 to R the data is already sorted. Now we have used two numbers which is N1 and N2. N1 is denoting what is the number of elements, or you can say what is the number of elements which are present from this location to this location, and then N2 is representing what is the number of elements which are presenting in this location. That means from here to here what is the number of elements, and N1 is representing what is the number of elements in this case. And then using those number of elements we have declared two array. Number one is the left array which is having a size greater than the original size. Then we have declared a right array which is having a size which is greater than the original size, and then we have copied this data to this array. From here to here we have copied this data to this array, and then here in this case we have copied all this data to this array, and then we have initialized the last index location with a very big value, that is infinity, and then we used a for loop k, this for loop, to copy this data back to the original array in a sorted manner. So this complete is your merge procedure, or you can say the merging procedure. Now using this merging procedure we are going to write the merge sort algorithm. So before going to the merge sort algorithm, just tell me what will be the time complexity of this merging procedure. Okay, so in any case take your time, pause the video and now try to see what will be the time complexity of this merging procedure. Now if you see this merging procedure, in this case you can see if you have n data elements, then all these spaces, all these equations are going to take some constant time. This equation is going to take some time which will be approximately, let us suppose if you have n data items and this point is at n by 2 location, then this is just copying this n by 2 data items to this location and this n by 2 data items to this locations. It actually depends on what are the number of data items and where the point Q is, where the point Q actually is. Okay, so if you are having n data items, then this will be taking approximately order of n time. This for loop will also be taking approximately order of n time, and this for loop will also be taking approximately an order of n time. Therefore, in the case of merging procedure, even if it is the best case or if it is a worst case or even if it is the average case, in all these three cases the merge sort procedure is going to take order of n time, or you can say theta of n time in case of average case and omega of n time in case of best case. Okay, now using this merging procedure, let us write a merge sort algorithm. Okay, so I'm going to use this space here so that we can have this algorithm in front, and then we can also have the merge sort procedure in the same way. Now what is this merge sort procedure? So we have merge sort which is going to take an array A as input. The first index location is P and the last index location here is R. Okay, then we have to do, if P is less than R, then we have to make Q is equal to P plus R by 2 floor value, and then we have to recursively call this function in such a way that we have merge sort A P to Q, then merge sort A Q plus 1 to R, and then we have this, we are going to call this merge procedure, which is merge A P Q R, right? So this is your merge sort algorithm. Now let us see how this merge sort algorithm is actually working. We have, as you can see here, we have some recursive calls. So we have to make a recursive tree in this case to identify all these recursive calls, and then we have to use the merge procedure here. Okay, so let me just clear this up and let us start with the blank slate here. Okay, now let us take a small example of an array and we'll apply this merge sort algorithm in this small array. So assume we are having this following array, which is having the elements which are 4, 3, 0, 11 and 46. Okay, now we have the index locations which are 1, 2, 3, 4 and 5. Fine. Let us number these lines. We have the line number 1, line number 2, line number 3 and line number 4. Okay. Now initially we are going to call the procedure which is merge sort on A P R. That means initially we are going to pass a reference to this array A. So we have A, the P is 1 and R is 5. That is merge sort A 1 5. Okay. Then here you can see the if condition. So if P is less than R, is P less than R? Yes, P is less than R. So we are going to make Q is equal to P plus R by 2 floor value. So Q will become 1 plus 5 by 2. So that is 6 by 2 is 3. So Q will become 3. Now we are going to execute line number 2 in this case. We have to execute the line number 2. So what is this line number 2 which is saying merge sort on A P Q. So we have merge sort on A P and Q which is 3. Okay. So again, because we are doing a recursive call, therefore in the recursive stack we cannot go back. We cannot in this case for this above function we cannot execute the line number 3 and 4. So in case of recursive stack, initially we have to identify what is this merge sort for the line number 2. Okay. So in this case again we are going to see is P less than R? Yes, P is less than R. Then Q is equal to P plus R by 2. Therefore the value of Q will become 1 plus 3 by 2, which is going to give us the value which is 4. So this value will become, the value of Q will become 4. Okay, sorry, this is 1 plus 3 by 2 which is equal to 2 here. Fine. And then we have this recursive call which is going to make merge sort A 1 comma 2. That means we are going to sort the data from 1 to 2. Okay. So here again this P is less than R. Yes, P is less than R. So we are going to make Q is equal to P plus R by 2 floor value. Right. So it is going to make 1 plus 2 by 2 floor value will be 1. So we are going to call merge sort A 1 comma 1. So now in this case, if you see P is less than R, no, P is not less than R. Therefore all these conditions, none of these conditions or none of these statements will be executed in this case. We'll go back to the original condition. So here we are going to call again, which is merge sort. This was the line number 2 and this was the line number 3. We are going to call merge sort A 2 comma 2 because it is Q plus 1 to R. So if you see this 2 is not less than 2 because the first condition is P is less than R. So this 2 is not less than 2, therefore the condition is failed. So we'll go back to the previous case. Again here in this case we have executed the line number 1, 2 and 3. So we are going to execute the line number 4 which is merge A P Q R. So that means we are going to call merge A 1 1 2. So that means here I am calling this function merge A P Q R. So what this function will do, we are going to copy the data which is from 1 to 1 into a new array with a very large value here. We are going to copy data from 2 to 2 into a new array which is having a very large value infinity. Then again we are going to have two loops. For here we have k, here we have I, and here we have j. Then we have to compare this data and this data. Obviously 3 is smaller than 4, therefore 3 will be copied here and then j will be incremented, and then 4 is less than infinity, therefore 4 will be copied here and then I is incremented, and this is the procedure what we are going to do here in this case of merge. As you can see, in this case we have merge sort 1 comma 2. From 1 to 2 the data is now sorted. Okay, so again we are going to go back into the previous case because this statement has executed all these four statements. Now we'll go back to the previous case. Now this statement has only executed the line number 2. Now this is going to execute the line number 3. Therefore it is going to call merge sort a 3 comma 3. Now when it is calling merge sort a 3 comma 3, in this case p is not less than r. So this p is not less than r because 3 is not less than r, 3 is not less than 3. So nothing will be executed here. So we'll go back to this statement, and this is now going to execute the line number 4, and line number 4 is going to say merge a 1 comma 2 comma 3. What it means, copy the data from index location 1 to 2 into a new array, copy the data from the index location 3 into a new array, and then merge all this data back to the previous array. So but in this case what we are going to do, we are going to copy this 3 comma 4, this 3 comma 4 into a new array, then we are going to copy this 0 into a new array. Again we are going to copy all this data back to the original array. So we have the pointer I and the pointer j. Now this 0 is less than 3, therefore 0 will be copied here, then j will be incremented. Now j is at the infinity, therefore all this data will be copied here. So 3 will come here and then 4 will come here. Now this statement has executed all its statements, all these 4 lines. So after executing all these 4 lines, that means you can see from 1 to 3, that means from the index location 1 to 3, all the data is already sorted. We have the data 0, 3 and 4. This is already sorted. Now we'll go back to the previous case here. In the previous case, because it has executed all its statement, so we'll go back to this statement, and this is now going to execute the statement number 3. So it is going to execute merge sort a 4 comma 5. Merge sort a 4 comma 5. That means we have to sort the data between 4 and 5. So for this case, initially we are going to find the value of q. So q will become 4 plus 5 by 2, which is 4. Now it is going to call merge sort a 4 comma 4, right? Nothing will happen. Then it is going to call merge sort a 5 comma 5. Nothing will happen, right? Then it is going to call merge a 4 comma 4 comma 5. That means we have to copy this data into a new array. We have to copy this data into a new array, and then we have to copy it back into sorted manner. So if you copy back, then data which you are going to get is 11 and 46 only, because it is already sorted, right? So after this statement has executed all its 4 statements. So we'll go back to the previous statement. Now it is going to execute the statement number 4. So statement number 4 is saying merge the data from a 1 comma 3 comma 5. That means merge the data from a 1 3 5. So it is going to call merge a 1 comma 3 comma 5. That means copy the data from 1 to 3 into a new array, copy the data from 4 to 5 into a new array, and then copy back. So this data, which is 0, 3, 4 and infinity, it will be copied into a new array. Then this data, which is 11, 46 and infinity, it will be copied into a new array, and then this data will be copied back. So when this data will be copied back, you can see the complete array is sorted now. So we have the array which is 0, 3, 4, 6, 0, 3, 4, 11 and 46. Okay, so this is a merge sort. So if this is not clear to you, what I will do is I will take one more example after clearing this up, and then from that example you are going to understand everything. So I am going to take sufficient number of examples in such a way that every topic will be clear to you in any case. Okay, now if any topic is not clear to you, then you can email me anytime, then I can make one more video for you so that you can understand everything. Okay, so this is a merge sort algorithm. So let us discuss about the time complexity of this merge sort algorithm. Fine.